In this video, we are going to learn the topics of photodiode, phototransistor, opto-coupler and photovoltaic cell. Photodiode. Photodiode is a two-terminal semiconductor device which is also known as a photodetector. The function of the photodiode is to convert light signal into electrical signal. Hence, it is known as light sensitive device. Photodiode consists of a P and N type region which is kept inside a glass casing. The arrangement is made in such a way that the light ray is accumulated and passed into the junction of the PN diode. The sides of the casings are painted to prevent the scattering of light. And from the diagram or the structure of the photodiode, we can able to find that we have some lines arrangement which will convert the light falling on it to the PN junction. And when light ray is passing into the junction of the reverse biased PN junction diode, the electron hole pairs are created in the depression region. This results in the generation of charge carrier which depends upon the intensity of light falling on the depression region. And here it is to be noted that the diode is to be operated in reverse biased conditions. And the symbol for the photodiode is given here, and we can able to find that the symbol is similar to a diode, but we are having a arrow mark moving towards the diode, which indicates that we have to make the light falling on it. The magnitude of the current produced is given by I equal to Is plus Is plus I naught into 1 minus exponential V by eta V1, and where Is is the current component of the light intensity and V is the applied voltage and Vt is the voltage due to temperature. That is, there are some voltages generated because of the thermally generated electron hole pair, and the value of eta equal to 1 for the germanium and 2 for silicon. That is, if the diode is made up of germanium material, then eta equal to 1. And similar to photodiode, we have the phototransistor. So phototransistor is a light sensitive semiconductor device which is not only used to convert electrical energy from light energy but also used to amplify. Hence it combines the operations of photodiode and amplifier. And we already find that the photodiode is similar to a phototransistor, but it has not having the capacity of amplify the signal. Since it is a transistor, you can easily understand that this device can able to amplify also. The emitter and collector of the phototransistor is connected to the region to the negative and positive terminal of the voltage. The base terminal is left unused and the light is made to fall on the base of the collector junctions. Then we can able to find from the structure of photodiode that the light is made to fall on the PN junctions here. And regarding the operations, when no light falls on the semiconductor or whenever no light falls on the transistor, the reverse saturation current is generated due to minority carrier ICO, that is a reverse saturation current. When the light falls on the junction, electron hole pairs are created and results in the generation of collector current. Here also we have the equation used for the collector current, and since it is an amplifier or it can able to amplify, this equation involves an amplification beta also, and the collector current is given by IC equal to 1 plus beta into ICO plus IL. Hence the collector current depends upon the applied voltage and the intensity of light falling on the junctions. And the symbol of the phototransistor, we can find that, and it will resemble like an ordinary NPN transistor, with one difference that an arrow mark is indicated that it is falling off light. So we can easily identify that a normal transistor from a phototransistor. Next we see the VI characteristics and applications of the phototransistor. And as for the VI characteristics, the characteristics of the phototransistor is the graph drawn between the collector current and the emitter to collector voltage. The value of the collector current, it is IC, increases when the light intensity is increases, and we can able to find from the graph here. Light we can able to easily find from the graph. And on the x-axis we have the voltage, and on the y-axis we have the intensity of light falling on it. And this graph is drawn for various intensity, that is 10 lux, 100 lux and 200 lux, and we can able to find that for the same voltage, and whenever the intensity of light is increasing, the current, that is the collector current, increases proportionately. Regarding the applications, the phototransistor is commonly used in light detector circuits, light dependent switches, counting of objects in production unit, and for reading equipments such as tapes, CDs, and another device which is working on the principles of optical energy is opto-coupler. Opto-coupler is also known as optical isolator or photocoupler. It is an electronic component that is used to transfer electrical signal between two isolated circuits by using light energy. As the name suggests, the opto-coupler is used to provide the electrical isolation between circuits. Hence it is known as optical isolator or opto-isolator. The structure of an opto-coupler consists of a light source, it may be an LED, and the photodetector with the transparent isolation cap between them to allow the light transfer. The structure of opto-coupler is shown here, and from this diagram we can easily understand that we have a light source here, and which emits light and which is falling on the photodetector. So whatever be the input signal that is given, that is converted into light source, and the photodetector once again that will convert it into an electrical signal. The LED is made up of gallium arsenide material, is used here to provide proper matching with the output circuits. The photodetector may be a photodiode, phototransistor, or even a photo-SCR. Commonly photodiode is preferred for its fast or very quick response. Next we will see how the opto-coupler will work. When the input signal is applied to the LED emit light signals. The intensity of light emitted depends upon the input signal or the intensity of the input signal, that may be the amplitude of the signal or whatever be the signal we given, depending upon that the current flow through the resistor and correspondingly the light is emitted from the LED. The photodetector provides the output signal based on the intensity of the light falling on the detector. Hence external current is obtained in the, so depending upon the voltage or signal, the light energy is emitted from here, and depending upon the intensity of light here, the transistor will conduct and the collector current vary, and we can able to get the output here. The basic characteristics of opto-coupler are: the light signal is transmitted with respect to the input signal in the range of megahertz. It is a frequency range. The opto-coupler provides isolation voltage of 500 volt to 2500 volt and isolation resistance in the order of 10 power 11 ohms. The output current will be stable for the temperature variations up to 75 degrees Celsius. It is this opto-coupler can able to operate up to a temperature of 75 degrees Celsius. The switching time of the opto-isolator is varies between or It may be based on the input current and the load resistance, and it may be in the range of micro. So next we are going to see about photovoltaic cell. Normally what we are calling it as the solar cell, and technically we are calling it as photovoltaic cells. The solar cell is a device that converts the light energy into electrical energy when the light, normally the sunlight, is passed onto it. It is also known as a solar battery or photovoltaic cell. The basic structure of the solar cell consists of a p-type silicon material and an n-type silicon material. So hence a p-n junction is formed between the p-type and n-type material. The sunlight is allowed to fall into the or on the junction through the. So from the construction diagram we can able to easily find that we have n-type region and we have a p-type region, and through a glass arrangement light is made to fall on this. Next we will see the operation, how the solar cell will operate. The incident photon in the form of light falls on the junction. The valence electron will gain enough energy from the incident photons and move towards the conduction band, so which in turn will increase the electron-hole pairs. The flow of electrons and holes across the junction will lead to the accumulation of carriers in the junction. Hence, this phenomenon gives rise to a photovoltaic voltage across the junction. That is, because of the accumulation of electrons across the junction, we find that photovoltaic voltage is generated across the junction. So the increase in the photovoltaic voltage depends upon the intensity of light fall on it. It is depending upon the light intensity of light. So the number of photons gets varied, and depending upon that the amount of power that is generated may gets varied. So if you look at the VI characteristics, which will give the relation between light intensity and output voltage generated, we find that the output voltage increases with the increase in light intensity falls on this cell. That is, whenever the light intensity increases, we find that the output voltage will get increases. The single solar cell can able to produce 0.6 volt for the incident sunlight. The average cell will produce about 20 milliwatts of power square inch from the cell, or we can able to generate this amount of power, and the efficiency of the solar cell can be obtained up to 40%. And regarding the applications, there are a wide variety of applications, and it can be used in satellite to provide required power. Almost all the satellites for generating power, they are using the solar cells, and power plants as a renewable energy resources, and they are also used in home appliances to provide required amount of power. And regarding the commercial applications, it is various commercial applications such as solar car, remote applications can make use of the solar cell. So these are some of the special purpose devices which uses the photonic energy to operate, so that they may be converted into an electrical energy, or they will convert electrical energy into some useful optical energy.